All right. Well, thank you for the polite calming down for us to get started. Thank you for joining us. I'm Greg Keston. I teach in the physics department and serve as Associate Director of Science Education on behalf of us at the Harvard University Division of Science, the Harvard Bookstore, and Harvard Libraries. I'm very excited to welcome you to this Harvard Science Book Talk with Professor Alan Lightman, who will be discussing his new book. Publication date is today. The Miraculous from the Material, Understanding the Wonders of Nature. And he'll be discussing with Dr. Logan McCarty. Before we get into that, if you want to know more about the series, events in it, you can just do a web search for Harvard Science Book Talks. You can do the same search on YouTube to see videos of past events. For example, you could watch last night's event, which Nobel laureate Jim Peebles was here, gave a wonderful presentation. And you can also, on our website, see that on December 3rd, we have Claudia Durham, who's talking about her book, The Beauty of Falling, A Life in the Pursuit of Gravity. But of course, back to tonight, we're very excited to have Professor Lightman, who is a novelist, essayist, physicist, and educator. He is professor of the practice of the humanities at MIT, where he was the first person to receive a dual faculty appointment in science and the humanities. He's the author of 7 novels, including The Transcendental Brain, The Accidental Universe, Probable Impossibilities, and he wrote the international bestseller, Einstein's Dreams. And Professor Lightman is also the host of the public television series, Searching Our Quest for Meaning in the Age of Science. And following a reading and his presentation, he'll be in conversation with Dr. Logan McCarty, who is Associate Dean of Science Education here at Harvard. He's also a lecturer on chemistry and chemical biology and lecturer on physics. In addition, he teaches in applied mathematics, and in collaborations with colleagues, he created and teaches other innovative and much-loved courses, such as What is Life? From Quarks to Consciousness, and most recently, a course that's really the first of its kind, Rise of the Machines, Understanding and Using Generative AI. An immediate hit with the students. So Professor Lightman's book has been praised. Kirkus says it's an eloquent survey of nature and the rewards that come from paying attention to it. So I, for one, am very excited for the rewards of us paying attention tonight to this wonderful presentation and conversation. A reminder that following the conversation, we'll have some time for Q&A. We'll come over to you with a mic, so just wait till the mic comes to you to ask your question. Try to keep it relatively brief. And then after the Q&A, we'll go over to the library, just up the stairs, across the hall. Some little nibbles, cheese and juice, and a book signing. So with that, Professor Lightman.
Can everybody hear me? Good. Thanks everybody for being here tonight. I'm going to start with a very short reading from the book, a couple of minutes, and then I'm going to show a few pictures and talk a little bit about the pictures, and then I'll have a conversation with Logan here, and then we'll have a Q&A after that. I call myself a spiritual materialist. By materialist, I don't mean that I drive Rolls Royces or wear Armani suits. I mean that I believe the world is made of material stuff and nothing more, and that material obeys rules and laws. At the same time, like many of us, I have spiritual experiences, and what I mean by that is feelings of connection to other human beings and to the larger cosmos, feeling connections to nature, communion, moments of communion with wild animals, the appreciation of beauty, wonder, nature is capable of extraordinary phenomena, and we human beings stand in awe of those phenomena. That's my view of spirituality. I became a materialist early in life. I loved to build things. I read in Popular Science or some other magazine that the time for a pendulum to make a complete swing, called its period, is proportional to the square root of the length of the string of the pendulum. What a fascinating rule, but I had to see if it was true. With string and fishing weight for the bob at the end of the string, I constructed pendulums of various sizes. I measured their lengths with a ruler and timed their periods with a stopwatch. The rule was true, and it worked every time without exception. Using this rule, I had verified I could even predict the periods of new pendulums even before I built them. Evidently, the physical world, or at least this little corner of it, obeyed reliable, logical, quantitative laws. At the same time I was forming these materialist views of the cosmos, I observed some amazing spectacles. With my microscope, I discovered an entire world invisible to the human eye. In a thimbleful of water from a nearby pond, I saw tiny creatures wriggling and gliding about, shaped like ellipses with little waving hairs, paramecia. Our family took vacations near Kentucky Lake, about 175 miles northeast of Memphis, Tennessee, where I grew up. Many mornings, if I rose early, I could see a mist hanging low over the lake. Ambers and lavenders and mossy green hues would refract in the air for an hour and then melt away like some rare species of plant. In college, I had my first look through a good telescope and saw the rings of Saturn. Anyone who hasn't seen them should. They are perfect circles. They are so perfect and pure that you think they couldn't possibly be real. You think that nothing in nature could attain such perfection, and yet there they were, almost 1 billion miles away, austere, cold, and crisp, floating in silent perfection. Understanding the material and scientific underpinnings of these spectacular phenomena hasn't diminished my awe and amazement one iota. So I don't believe in miracles, but I do believe in the miraculous. The miraculous abounds, and the natural world and its laws are quite enough to explain it, and that too is miraculous. Well, my book consists of 35 chapters, and each chapter begins with a full-page color photograph of an extraordinary phenomena, and then there's an essay that I write that explains the science behind the phenomenon and my personal experience with it. For example, there are spider webs, galaxies, volcanoes, lightning. There are very weird cloud formations called mammatus clouds. This elaborately colored fish, the mandarin fish. Rainbows, bioluminescence, and bubbles. These are just some of the phenomena in the book. They're all beautiful pictures, of course. So let me say a few words about some of these phenomena, and let's start with the gorgeous fall colors. And of course, living in this part of the country, we're all treated to seeing the beautiful fall colors. So what makes such striking colors? Well, the answer is a large planet that hit the Earth 4 billion years ago. But I'll get to that part of the story in a minute. Here, as in so many phenomena of nature, the appearance of one thing is caused by the suppression of another. And in the case of forests and their leaves, the yellow, red, and orange pigments that we see in the fall are always there in the presence of two chemicals. One is called carotenoid, I'll just call that chemical A, and the other chemical, anthocyanins, I'll call that chemical B. The chemical A is responsible for the orange and yellow colors in things like carrots and corn. Chemical B is responsible for the red colors in things like apples and cherries. And during most of the year, these pigments, the reds and oranges and yellows, are totally masked by the green of chlorophyll. So they're there, but you can't see them because they're masked by the chlorophyll. And of course, chlorophyll is found in all plants and helps supply their energy. During the growing season, chlorophyll molecules are being constantly produced and assembled and then disassembled. But in the autumn, sunlight is less plentiful, and the growth of the production of chlorophyll slows down. And that slowdown reduces the chlorophyll and allows the reds and oranges and yellows to come out. So I'll end with a scientific story about the ultimate origin of the fall colors. Because all growing things depend on sunlight and temperature, they have life cycles following the seasons. Our seasons, in turn, are caused by the tilt of the Earth. That is, the angle between the Earth and the plane of the orbit about the sun. And in the summer months, the northern hemisphere points towards the sun. That's the right-hand diagram if we're the northern hemisphere. And in the winter months, the axis of the Earth points away from the sun in northern latitudes, and that's our winter. So if the Earth's axis were parallel to the perpendicular, if it were totally perpendicular to the plane of the orbit, there would be no tilt. And no tilt, no seasons, no fall foliage. So, but what caused the tilt? Well, it was a cosmic accident several billion years ago when the solar system was forming. We think that our solar system formed from a rotating cloud of dust and gas, and most of the material in the early solar system was orbiting in the same direction. That's why all the planets orbit the sun in the same direction. But there was some renegade material that didn't orbit in the same direction as everything else, and a large chunk of that hit the Earth and cocked it on its axis. So while the Earth has a tilt of 23.5 degrees, Uranus has a tilt of 82 degrees, and Saturn has a tilt of 26.7 degrees. Mercury is the only planet in our solar system that was not hit by a large mass, and it has almost no tilt. And for that reason, Mercury has no seasons. So if it had trees, it would not have fall foliage. So in sum, one can say that our gorgeous fall foliage originated in a random cosmic collision during the history of our early solar system. So this is an example showing that accidents can sometimes lead to great beauty. Well, let me talk about another chapter in the book. And this is the mandarin fish, and it gets its name because it looks like it's wearing the robes of a Chinese mandarin. It can be found in warm waters. It's a little fish, about 3 inches long. And of course, the most striking feature of these mandarin fish are their extravagant color. So where do they get that extravagant coloration and why? Almost every distinctive trait of a living organism is the result of natural selection. It had survival benefit over millions of years of evolution. And regarding coloration in particular, Charles Darwin wrote that when we see a leaf-eating insect that is green and a bark feeder that is brownish gray, we must believe that these tints are in service of protecting them from danger. Well, in this case, Darwin was talking about coloration to provide camouflage. But coloration has other survival benefits. It can be used to attract mates. It can also be used to warn predators if it's very poisonous. If poison is its survival strategy, it needs to warn predators that it's poisonous so that they will know to stay away before they eat it. So if you're poisonous, you want your potential predators to know very quickly to stay away. And there are other examples of poisonous, elaborately colored animals. Here's the coral snake. There's the poisonous dart frog. And mandarin fish are poisonous as well. That's their defense mechanism. This modest little 3-inch fish has tiny spines that inject a poison if you try to bite into it. The mandarin fish's most dangerous predator, its most natural predator, I should say, is the scorpion fish, which also packs a lot of poison in itself. But an equally lethal predator is us human beings, because mandarin fish are so beautiful and exotic that they are collected for recreational purposes and put in fish tanks. They can cost as much as $150, but they don't last long in captivity. In the wild, they last 10 to 15 years, but in a fish tank, only 2 or 3 years. So there's an irony here. The exotic color of the mandarin fish, which warns predators of its poison and protects it in the wild world of the ocean, that same color is a liability when it comes into contact with the human world. An interesting irony. So let me say a little bit about lightning, which is maybe one of the most dramatic natural phenomena. It's basically a flow of electricity. So to explain electricity, I have to go into science just a little bit. Probably most of you know this. An atom has a positively charged center, and then it has negatively charged electrons, subatomic particles, that orbit at great distance around the center. And in most atoms, there's an equal amount of negative and positive charge, so it's electrically neutral. And I know that Logan knows a lot more about this than I did. Studied it for his PhD thesis, among other things. So the origin of lightning is a separation of electrical charge within a thundercloud. And one of the ways that this separation occurs is by friction. When you have warm water vapor rising up from the earth, and it rises due to buoyant forces, it's less dense than the cool air around it. It rises, and as it meets the cooler air in a thundercloud, by friction, it rubs against those cooler air molecules, and electrons, those subatomic particles in the outer part of the atom, they're stripped off. And so the rising water vapor that now is condensed into warm water, as it rises to the top of the cloud, it's positively charged because its electrons have been partly removed. And the colder air that received those electrons, it's heavier, it sinks to the bottom of the cloud. It is negatively charged because it has received those electrons from the warm water vapor. So you have a negative charge at the bottom of the cloud and a positive charge at the top. That separation of charges, of electrical charges, is called polarization. There's a further polarization because the bottom of the cloud, which is negatively charged, attracts positive charges in the ground, opposite charges attract. And so you have a positively charged ground, negatively charged bottom of the cloud, and positively charged top of the cloud. All of this because electrons were stripped off the water molecules rising up in the cloud. And once you have this charge separation, you get an electrical force that tries to accelerate electrons from negative to positive. The air normally acts as an insulator, but once the electric force gets strong enough, the electrons get ripped off the air and they go surging to the ground, and that's a lightning bolt. The lightning bolt only lasts for about 30 millionths of a second, but that's enough to power a typical household for about 10 days. Well, let me go to another natural phenomena, and first I'll just talk about spirals, and then I'll say how it appears in nature. We've been fascinated by spirals for thousands of years. The eye starts at the center of a spiral and winds around, never quite coming back to where it started, but staying near the center. The oldest spiral that's ever been found, human-made, is in a tomb in Ireland dating back to 3200 BC. Now it happens that many plants have a spiral pattern. Here's the polyphila plant. A lot of not just plants, but a lot of natural things have a spiral pattern. And many growing things in nature exhibit a particular kind of spiral called the Fibonacci spiral, in which the length of each quarter turn is equal to the sum of the lengths of the two previous quarter turns. Now that may sound pretty technical. The nautilus shell has the Fibonacci spiral. The seed pods of the sunflower plant have the Fibonacci spiral, and many other growing things have a Fibonacci spiral. Why? In 2004, there were two scientists at the University of Arizona in Tucson who calculated the stresses on the cells of a plant as it was growing and as the plant is twisting around, and they found that those stresses are minimized when the plant forms the Fibonacci spiral. And nature always takes the path of minimum energy when it's given a choice, unlike human beings. Now we enter the kingdom of magic. There was a 12th century mathematician named Leonardo Fibonacci who discovered a very interesting series of numbers called the Fibonacci series. Each number in this series is the sum of the two previous numbers. 2 is equal to 1 plus 1, 5 is equal to 2 plus 3, 8 is equal to 3 plus 5, 21 is equal to 8 plus 13, and so on. That may ring a bell when I said that the Fibonacci spiral is a spiral where the length of each quarter turn is equal to the sum of the two previous quarter turns. Now, if we form a series of squares, the sides of which are the Fibonacci numbers, so 1, 3, 5, 8, 13, 21, and we connect the opposite corners of each square, we get a spiral which is the Fibonacci spiral. Has anybody heard of the Fibonacci series or spirals? A few people nodding yes. Oh, that's a lot. Well, you guys are very mathematically inclined. Now, there's even more to this natural magic, and I consider this whole book to be natural magic. Biologists, architects, sociologists, and anthropologists have long noted that we human beings really like the Fibonacci spiral. We're aesthetically drawn to it, whether consciously or unconsciously. First of all, here I superimposed the Fibonacci spiral on the polyphila. But now let's get to human beings. There's the Taj Mahal, and I have superimposed the Fibonacci spiral on ever-increasing, ever larger structures of the Taj Mahal. So one could conjecture that the people who built the Taj Mahal, maybe at an unconscious level, had the Fibonacci spiral in their minds. The same is true of the Notre Dame Cathedral. So this special series of numbers manifested in the spiral patterns of plants and shells is a set of proportions that we human beings find aesthetically pleasing. And it's really not that surprising that we human beings find this spiral aesthetically pleasing, because they are part of nature and we are part of nature. For me, these spirals from the Fibonacci series to the series in plants and our own aesthetics represent a profound connectedness of all living things. We are part of a whole. Well, the last chapter that I'm going to describe before I get into the conversation with Logan is a natural phenomena that I think is at least as great or maybe greater than all the other natural phenomena that I've shown, which is the human being. We human beings have created the Great Pyramid of Giza, Beethoven's Ninth Symphony, Rembrandt's paintings, the Romance of the Three Kingdoms, Macbeth, the Ramayana, London, Paris, Singapore, the theory of relativity, antibiotics. We've created all of that with our human minds, with our brains. We have a substantially larger brain than any animal of our size. And I really can't come close to describing or even understanding all the aspects of human beings, so I'm just going to focus a little bit on our brains. And I would argue that our brains, with 100 billion neurons, are the most complex object that we know of in the universe. They're more complex than galaxies, they're more complex than volcanoes or black holes. And the most spectacular phenomena of our brains, the most fundamental phenomena, is our consciousness. This feeling of being present in the world, of having a self, of having an autobiographical memory, of being able to plan for the future. Even though we can't fill in all the blanks to get from the physical neurons, and I said I was a materialist, so I believe that every mental sensation, including consciousness, is rooted in the material brain, we can't fill in all the blanks to get from those neurons to this spectacular sensation that we have, that we call consciousness. But there is some way to understand that, and that is in terms of emergent phenomena. These are phenomena where a system has many, many parts, and even though you may understand the workings of each individual part, you don't understand qualitatively the behavior of all those parts working together. An example of that is a certain species of fireflies. You let them out into a field on a summer night, and at first they blink randomly like Christmas tree lights, but after a minute or so, they start blinking in synchrony. We understand very well how individual fireflies work, but we don't yet understand how a large group of fireflies comes into synchronous flashing. And in the same way, our brains have 100 billion firefly-like neurons, many more neurons than there are fireflies in that picture. We understand pretty well how individual neurons work, but when you put a large number of them together, you get emergent phenomena. And I would claim that that our consciousness is one. And let me end with a few words about us human beings, which I argued was the most, our brains are the most complex object that we know of in the universe. We human beings have evolved to where we are over a couple of million years. But now with the exponential advance of technology, we have bypassed Darwinian evolution, and of course ChatGPT is one example of that. And we even are able to put computer chips into people that are totally paralyzed that allow them to move robot arms by pure thought. This guy here is Eric Sordo, who I met a few years ago. Right under our eyes, right under our noses, I should say, Homo sapiens is transitioning into something that you might call Homo techno, part human and part machine. That's what's becoming of us. And this is happening not in millions of years, but it's happening in single human lifetimes. I mean, who knows what computers and AI are going to be like even 20 years from now, or what computer parts we're going to have in our bodies. We are modifying our evolution by our own hand. We are remaking ourselves. So no one can guess what Homo techno will be like several hundred years from now. But it's my hope that several hundred years from now, that we will still feel awe when we look up at the night sky. I hope that we will still write books and symphonies. I hope that we will still fall in love. And I hope even that we will still feel anger and jealousy. And I hope that we will still have hope. Thank you.
Alan, thank you so much. Okay, good. So let me engage in a few questions here, and then we'll open it up to some questions from the audience. I'm sure you have questions. I'm fortunate to be perhaps one of two people here who's read the whole book. As today's the publication date, but I was able to secretly get an advance peek at the contents of the book, and I read all of it with great delight. Tell me about the genesis of this book. Did you start writing these essays and then say, oh, I want to put 35 of them together in a book in alphabetical order? And, you know, how did you stop? 35 is a good number?
Well, the genesis, I'm a jogger. I used to call myself a runner, but in my old age, I call myself a jogger. And I was running by a field near our house early in the morning, and there was a low mist hanging over the ground. And it was just a very beautiful sight. I'm sure that everybody here has seen mist hanging over the ground. It burned off after a few hours. And I went home and I began thinking about what caused the mist. And so that was a case where there was a beautiful visual phenomena that I wanted to connect to a scientific explanation. So that started the book off.
So that's the chapter, Morning Mist. And did you then, did you have in mind certain scientific topics that you knew you wanted to include? So for instance, the fact that seasons are formed because the Earth tilts on its axis. There's a famous video called A Private Universe where they interview a bunch of Harvard College graduates and they ask, why are there seasons? And half of them say, oh, well, the sun is close, the Earth is closer to the sun at certain times and further from the sun at other times, which of course is completely wrong. And these are, you know, people graduating from this august institution. So did you have in mind at least like a checklist? Well, I want to make sure I get the axis tilt of the Earth. Or
No, I did
want
not.
the hexagonal structure of ice in water molecules in ice?
No, I did not start off with a list of scientific topics. I started with extraordinary visual phenomena that I had seen and that I felt an emotional connection to. And I think that that's where a lot of, I mean, we think of science as a sort of dry, sanitized, intellectual, quantitative activity. But I think that our science, like so many things, started with our emotional response to the world. Certainly our art, and I think our science as well. So that's where I started with phenomena that I had seen that really stirred me in some way. Then, of course, I had to find a beautiful picture. And if I couldn't find a beautiful picture of the phenomena, then I had to go pass on and go to another one. But if I then found a beautiful picture, then I would begin thinking of the science behind the phenomena. So that's the order of events.
So it's called the miraculous from the material, but you started with the miraculous.
I started with the
and then worked
miraculous.
backwards.
I started with the miraculous. Yes, that's right.
So you get that sense of awe and wonder in the book, but there's some interesting quotes you say. For instance, this is in the discussion of the Yosemite firefall, right? That moment when the setting sun happens to light the waterfall at El Capitan at just the right moment.
And it looks like that there's lava pouring from this mountaintop.
For those of you who have the book, it's in the picture.
Yeah.
Yeah.
It looks like there's, yes.
It looks like, magma flowing over the...
It looks like magma, but it's just sunlight reflecting off water.
And you say in the book that knowing the material causes does not in the slightest diminish the amazement and majesty of the spectacle. And yet you're trying to sell us a book on knowing the material causes. And does it enhance the spectacle for you in that moment?
Well, for me, it does enhance it. And knowing the science behind the phenomena, for me, doesn't diminish that emotional splendor. I don't know what other word, the majesty of the thing. So it just gives me another way of thinking about it. But in the end, I'm just experiencing the phenomena.
You say about hummingbirds, when I look at these birds, I don't think numbers or gravity or heat dissipation or evolution. I just watch and I'm amazed.
Well, yes. The very last chapter that I talked about here was us human beings.
Yeah.
And the human brain as being one of the most amazing objects in the universe. And so to me, the scientific explanations represent the workings, the power of our human brains. And that is another natural phenomena. You can't see it from the outside. It's hidden. But the fact that our human brains, and for a scientist, the brain and the mind are the same thing. The fact that we're able to give the explanation to rainbows and mandarin fish and lightning, the fact that we're able to develop theories of the beginning of the universe, the Big Bang, the fact that we're able to create antibiotics, the fact that we're able to discover what are the molecules that encode instructions for making other human beings. To me, that is a marvel like the colors of the mandarin fish or the lava flowing from the Yosemite. So it's all of a piece.
And reflecting on the natural phenomenon and understanding that we humans now understand that is like a meta level of amazement, right?
Yes.
So you say in your book that you believe that there is intelligent life elsewhere in the universe. Tell Tell me, is there evidence for intelligent life on this planet? But more seriously, tell me about you seem persuaded that there's intelligent life elsewhere in the universe.
Well, a satellite called the Kepler satellite that we flew, went up 10 years ago, I can't remember exactly when, looked for habitable planets. Mm-hmm. That is planets that are the right distance from the central star to have liquid water. And biologists think that you need liquid water for life, although it doesn't have to be anything like our life. And they concluded that maybe 10% of all planets, of all solar systems, have habitable planets. Well, there are 100 billion solar systems just in our galaxy, and there are 100 billion galaxies that we can see with our telescopes. So the probability of there being no other intelligent life in the universe is like the probability of having 1 million dry forests and none of them catching fire.
Yeah, I mean,
it's just, I mean, that doesn't mean that we're going to come into contact with the other intelligent life out there, because the distances in space are so huge that we may never have contact. But it's almost certain that it's out there.
So, since I teach a class on this, tell me about your view on AI, which you just mentioned at the end there. Is that another type of intelligence, or potentially another type of consciousness that is inhabiting the same planet that we are?
Well, let's talk about consciousness. I think consciousness is a feeling. First of all, it's a sensation that we have. And I think that if you made a list of the manifestations of consciousness, like self-awareness or like ability to plan for the future, any finite list of manifestations of consciousness that you make, I think that a computer will be able to check all the boxes, not right now, but in the near future. But whether the computer is actually conscious is another question, because to answer that question, you would have to know what the computer feels. Consciousness is a feeling. It's a sensation. And we may not know what a computer actually feels. So it may be able to do all kinds of fantastic tasks, but whether it's actually conscious is a question that may be difficult to answer. I mean, I know that I'm conscious. I don't know for sure that you're conscious.
But I know that I'm, yes. So I think on that note, why don't we see if there is intelligent life in this room?
I'm sure there is.
I'm sure there is. And conscious life in this room, and take some questions from the audience. So please wait until we have a chance to bring the microphone to you for your question. Yeah.
If the mandarin fish turns out to be maladapted to the presence of humans because we're attracted instead of repelled by its coloring, is that causing evolutionary pressure on the species that we can detect?
What is that doing to the species? I didn't get quite the last part.
Is there evolutionary pressure on the mandarin fish to adapt to the fact that we're attracted to it rather than repelled by it, and that's causing declines
well, that's a great
in population?
question. And I think that if there were enough mandarin fish that came into contact with humans over a period of time, I think there could be some adaptive change to us. I mean, I think that the fraction of mandarin fish that get put into recreational fish tanks is a small fraction of the total number of mandarin fish.
We're not endangering it.
No, I don't think we're endangering it as a species. Yeah, but it's a great question.
Another. Yeah.
You are a spiritual man, and I'm very familiar with Zen or Taoism. I'm wondering, I think there's the thread of thought that when you name something, you limit its ability to be understood. And so I'm wondering, can you speak, as you write about these natural miraculous, how you can reconcile this other thought?
Well, that's also a wonderful question. And I do think when we name something, we are limiting it. Are you a linguist by any chance, or a psychologist? Yes, okay, yes. Yes, well, the great linguist Noam Chomsky is at my institution, MIT. Language, now I'm speaking out of my depth, okay, so I'm not an expert in this, but language is necessary on the one hand, and on the other hand, it is necessarily limiting. I think that we can experiencing things without naming them. And I think that if I just use my book as an example, the pictures convey something that I cannot express in words. It's first and foremost a picture book. And we respond to these phenomena emotionally and aesthetically before we give them names or before we try to describe the scientific basis for them. But it's a very good point that you make.
Hi, I want to go back to something you said earlier in your talk when you were talking about techno-homo and a new era of, I guess, being able to, select our traits in some way. I was curious if you had, now that we're able to maybe control these things more than we were in the past, if you have any guidance on how we can responsibly use this power.
Well, that's a very good question. I think that, let's talk about AI, which is one aspect of your question. I think it's going to be very hard to control AI. I know the European Union has tried to pass some legislation governing the countries in that union, but the profit motive is so huge. The incentive to make money is so huge that it's going to be very difficult to control it. I know that different governments are going to attempt to control it. The UN is going to make some recommendations to the member states. But since it's developing so rapidly, even more rapidly than the leading practitioners can keep up with, I think it's going to be difficult to control. I don't know exactly what the future holds. I'm hoping that there will be some self-regulation that takes place. But, we can see, even with such simple things as hearing aids and eyeglasses, that we're already modifying. We've already gone off the track of Darwinian evolution, even now, before AI. And I think AI is going to just send us further off that track. And I just hope that we can preserve some of the qualities that we cherish as being Homo sapiens. But who knows what we're going to be like 500 years from now.
Thanks. So I was browsing the book, and I noticed that you begin the essays with Emily Dickinson poem or Rumi in the Mist section, and also Tolstoy. So was this a function of your literary style, or was it deliberate in kind of two ways of seeing nature? Like one is scientific, and then the intuitive, poetic view of these phenomenon. And some of these people, Rumi lived in 12th century, Emily Dickinson, 19th century, and sometimes their insights were as powerful as, modern science. So I just want you to comment on this, the poetic, intuitive approach to understanding nature and the cold scientific methods, and whether at some point one can unify these two ways of looking at.
So you're asking why do I have the literary quotes at the beginning of each chapter, like a poem of Emily Dickinson or a few lines from Rumi and so on? Well, I like to think that I'm a literary writer. I've written a bunch of novels and as well as essays and nonfiction books. And I don't like to see a sharp separation between the sciences and the humanities and the arts. I think they're all part of being human, and it is important to study chemistry and the tools of chemistry, and to study history and the tools of history. There are different methodologies and tools of different disciplines, and it's important to develop those tools. But it's also important to realize that we are complete human beings. We have a scientific side, we have an artistic side, we have a humanistic side, we have a philosophical side, we have a theological side. And so my putting some literary material in the book is perhaps a feeble attempt to show the wholeness of human beings. And as a writer, I write both fiction and nonfiction.
Thank you very much, a wonderful talk. I only have one comment, is on your understanding of the human consciousness. Actually, the best group of people to address this question is from our Mass General Hospital, Brigham Women Hospital, for the anesthesiologists. And you can see when the patient was under, the medications, they drop from a conscious level to a slowly titrating down to somewhere in between. Well, you can call subconscious or semi-conscious, and then to unconscious. So based on the kind of, common observation is that, consciousness is more like a awareness, a cognitive, perceptive, event. For instance, where I'm in this room, listen to your wonderful talk. And the last thing is that if I want to address this question, I will ask another question, what about, the structure of consciousness is, what are the basic components you need to put together to build a consciousness? If you can address this question, you can answer and understand the nature of consciousness. Thank you.
Well, I'll just make one comment. Thank you for your comment. Whatever consciousness is, it's surely a graded phenomena. It's not an all or nothing thing. And we know that dolphins can recognize themselves in a mirror. We know that crows can play with each other. And so these are some aspects of consciousness, not at the level of human consciousness. So that's one comment, that it's a graded phenomena, that it surely exists at some level in non-human animals. But we all can also see this decrease of consciousness that you were referring to medically in people that have varying degrees of dementia. And I'm sure that everyone in this audience knows someone or maybe a family member who has Alzheimer's or some other form of dementia, which is very sad to see. And as dementia progresses, first the person loses track of where they are, then they lose track. They might lose some memories. So they could still be self-aware, but they might lose memories. And autobiographical memory is a large part of our self-identity, and I would argue it's a part of an advanced level of consciousness. So we can see this continuum of attributes that we might associate with consciousness, as well as being able to see a gradation of consciousness in non-human animals like dolphins and crows and other animals.
Brilliant talk. I really enjoyed it. When you were talking about the Fibonacci and like the constraints that nature follows, my mind went to the moment of inception. When there was hundreds of degrees of freedom and anything could have happened. And it so happened that because we came up, after the Big Bang with maybe some preliminary molecules featuring the carbon atoms, that they probably evolved into amino acids and then gave rise to life on the planet. But it occurs to me that if those carbon molecules or atoms were not involved, and maybe it was silicon or something else, this could just have been a planet of glass and rock. So what a beautiful coincidence that it turned out to be something organic instead of just granite.
Yes, well, I'm very happy that I live in the universe that I live in. Just
Thank you very much. So I'm here. So I'm actually wondering, you said you finished with the human species, and then as a psychologist, the first thing that came to my mind was, what role would people that cannot have, like that don't have the luxury of having a functional brain play in this? Like what's their position in all of this miraculous world? And
what role do people who don't have, I didn't catch that word.
I mean people with mental disorders, or people that where all the neural communication does not work as it's supposed to be working in order to build something constructively, in order to live in this world. How can we look at them, and how can I get a broader perspective on this when I look at it from your perspective?
Well, I think you're answering a question in psychology and sociology, perhaps, and I'm not really qualified to answer the question, although it's a great question. So I'm sorry for that.
Let's do one more, and then we have the reception across the hall. Yeah.
Thank you for the lovely presentation. I wanted to get back to the discussion about the intersection between the arts and science and discovery. And I'm curious what your thoughts are on why we, at higher educational institutions like Harvard or MIT or hundreds across the United States, aren't able to access in a way that cross-disciplinary learning in a higher level. So I think we tend to silo like the sciences and the arts. We're not able to understand that the artists and the scientists working together can come up with the discoveries that you're talking about.
Well, first of all, I think that that it's important to have the separate disciplines that we do, because there are certain particular tools that each discipline has, certain ways of thinking about problems, which is useful to have different ways, different tools in your toolbox. We wouldn't want everybody on planet Earth to speak the same language, where there's a richness and a diversity of having the different languages. And there's a richness to having different tools with which to attack problems. At the same time, there are certain problems like climate change that require many different disciplines. It's a problem of chemistry, it's a problem of physics, it's a problem of sociology, it's a problem of psychology, it's a political problem. And for those problems, it's very important to have people to cross disciplines. It's important for institutions of higher education to have interdisciplinary courses that might be team taught so that you can look at problems from different perspectives. So I don't know whether that answers your question, but I'm just giving you my opinion.
So
let's thank the speaker and in conversation again.
thank you.
Thank you, Logan.